Hello again. In our last video, we studied graphs, intercepts, and symmetry. Now we're going to begin studying one of the most important ideas in algebra and precalculus. And that idea is this word here, slope. Slope is very important. Slope measures how one quantity changes compared with another. More specifically, slope tells us how much the y changes when the x value changes. So let's begin with the basic formula. The basic formula for slope is y equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Or another way of looking at this is m equals delta y divided by delta x, okay? Or the change in y divided by the change in x. So the symbol m represents the slope. The numerator measures the vertical change, right? Because the y-axis is up and down. And the denominator represents the horizontal change, right? Left to right. Now, you may also hear this described as rise over run. So let's begin looking at some examples. Let's find the slope for point A, which is 1, 2, and point B, which is 5, 10. Let's identify the coordinates first. Let's say we're going to use x sub 1, y sub 1, and we're going to say that that is 1, 2. And then let's use x sub 2, y sub 2, and we're going to say that that is 5, 10. So it's best to establish the points that you're going to use so that you don't make a miscalculation. Now, let's substitute this into the slope formula. So the slope formula, again, is m equals delta y, delta x, y sub 2 minus y sub 1, x sub 2 minus x sub 1. So y sub 2 is 5 minus y1, which is 2. Or excuse me, I made a calculation error right there. So y sub 2 is actually 10, and then y sub 1 is actually 2. Forgive me there. So again, y sub 2 minus y sub 1, and then finally x sub 2, which is 5, minus 1, which is x sub 1. So now we have 10 minus 2 divided by 5 minus 1. 10 minus 2 is going to be 8. 5 minus 1 is going to be 4. 4 goes into 8 2 times. So m is 2, or the slope is m equals 2. What does that mean? It means that for every increase of 1 unit in x, y increases by 2 units. So one way of thinking about it is you got to understand that even if you have a whole number, you should always, in most cases, understand this, that m equals 2 is actually 2 over 1. So for every change in 1, we go up 2, right? You run 1 over 1, and you go up 2, which is why we have the whole idea of rise over run. So another way to think about this is you can write the 2 as 2 or 2 over 1. Both answers are true. And so when you're giving the slope, it's best to understand this right away. Let's look at another example. This will be example 2. Let's find the slope for point A, which is 2, 7, and point B, which is 6, negative 1. So again, we want to write the slope. And I'm going to skip this step over here that I did earlier. We're just going to substitute to save some room. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to say that this is my x1, y1, x2, y2. So y2 is going to be negative 1 minus 7. And I'm going to divide that by 6 minus 2. Now, we need to understand that this is the additive inverse. So this is actually negative 1 plus a negative 7. And a negative 1 plus negative 7 is going to give me a negative 8. Divided by 6 minus 2 is going to be 4. A negative divided by a positive is going to give me a negative. So this is negative 2 or negative 2 over 1. And again, both of those answers are true. So m is equal to 2 or negative 2 or negative 2 over 1. So a negative slope means that x increases, y decreases. So the further you go, so for every 1, we're going horizontally, and then the 2 says that we're going to go down. So the way it looks is, suppose you have a point here, you're going to go over 1, down 2, over 1, down 2, over 1, down 2. So over 1, down 2, over 1, down 2, over 1, down 2. So that's how this would be perceived. So 1, down 2, 1, down 2, 1, down 2. Whereas up here, it was the alternative. It was if this is the starting point, you're going to go over 1, up 2. So over 1, up 2. And that's an increase of a positive 2. Okay, so that's how you got to understand the slope. Now, positive slope, it rises from left to right. Negative slope falls from left to right. Okay, let's look at another example. Example number 3. We're going to have the same points. Got ahead of myself over there. And reverse order. So let's find the slope for A is 1, 3 and B is 4, 9. Okay. So again, it's best to establish these as such. So M is going to be 9 minus 3. X is going to be 4 minus 1. This is 6. This is 3, which is 2 or 2 over 1. So the slope is m equals 2 or 2 over 1. Now, let's reverse the order of the points. Okay, so let's reverse the order of the points. Let's say that we're going to use, as a matter of fact, let me write these here. Let's say we're going to say that this is x2, this is y2, this is x1, this is y1. So in replacing this, we're going to say 3 minus 9, 3 minus 9, and we're going to say 1 minus 4, 1 minus 4. 3 minus 9 is going to give me a negative 6. 1 minus 4 is going to give me a negative 3. Well, a negative divided by a negative is a positive. 3 goes into 6 2 times, or 2 over 1. So notice we switched the points around, and so we ended up with the same result. So the answer is still the same, and that's important. You may subtract in either direction, but you must remain consistent. So if you want to use the first points as x2, y2, or you want to use the second points as x2, y2, you're going to end up with the same result. If you begin with y2 minus y1, then the denominator must be x2 minus x1. Do not reverse one without reversing the other. So a common error is, students, let's just say a student uses the points 1, 3, and 4, 9. Okay. Let's say they do that and they write m equals 9 minus 3, 1 minus 4. And then they compute 6, negative 3, m equals negative 2, or negative 2 over 1. What do you think about this? The student made a mistake. The student is wrong because the subtraction order is inconsistent. The numerator uses the second point, minuses the first point, but the denominator uses the first point minus the second point. So the order must match. It must be consistent. Okay, let's do example number 4. Example number 4, find the slope between point A, negative 3, 5, and B, 4, negative 9. Okay, determine the slope. So first of all, M equals, and let's just establish the points, x1, y1, x2, y2. Negative 9 minus 5, negative 9 minus 5, divided by 4 minus a negative 3. Okay? So in computing this, we have negative 9 minus 5, which is going to give us negative 14. Then we have 4, and again, this, anytime you see the two minus signs, you need to know that it becomes addition. So 4 plus 3 is going to give me 7. M is therefore negative 2, or negative 2 over 1. So notice the denominator. The denominator is 4 minus a minus 3, and that's a positive 7. This is another reason parentheses are important when negative coordinates are involved. Now I want you to try this. -2, -5, and 6 comma 7. Okay, pause the video and solve it before continuing. Okay, let's solve this together. So again, there's multiple ways to do this, right? So you may not choose the order that I did or the order that I'm going to choose. You may choose a different order, and that's perfectly fine. We're going to arrive at the same location, which is nice. So 7 minus a -5 and 6 minus a -2. And again, 7 minus a -5, 6 minus a -2. So those two minus signs make it a positive. And I end up with 12. Those two negative signs make it a positive. I'm going to end up with 8. This can be simplified. The common denominator of, or a common factor of these two terms, and the way you want to think about common factors is what two numbers multiply to give me 12. That's 1 and 12. You also have 2 and 6. You also have 3 and 4. Okay, so 1 times 12, 2 times 6, 3 times 4. And then for 8, we have 1 times 8 and 2 times 4 and nothing else. So what is the greatest number that they have in common? They have a 4 in common. So we can essentially divide the top and the bottom by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. Okay? And so that is the slope. We have our rise, we have our run. There's no need to divide by 1 because it's not a whole number. So therefore, the slope is 3/2. And so this means that for every increase of 2 units to the right, we're going to vertically increase 3 units up. So that's 2 units over, 3 units up, 2 units over, 3 units up. And that is how we determine that. Now, example number 5. Let's interpret meaning. Suppose the cost of renting a vehicle is modeled by 2 data points. Okay. Suppose the cost of a vehicle is modeled by 2 data points. That data point is 185. Okay. And 300 and 125, where X represents the miles driven X represents the miles driven, and Y represents the total cost in dollars. Okay. So X represents the miles driven. And Y represents the cost in dollars. So 100 miles and the cost it takes, 300 miles and the cost it takes. Okay. Find the slope or find the slope of this particular equation. So how do we do this? We take M, which equals the change in Y, the change in X, and we say, all right, I'm going to say this is X1, Y1, X2, Y2. So 125 minus 85 divided by 300 minus 100. 125 minus 85 is 40, and 300 minus 100 is 200. This simplifies to M equals 0.20. So the slope is 0.20. And again, you can also write this as 0.20 over 1. But in a problem like this, in an applied problem, giving only the number is really incomplete. We must interpret it. Okay. So the units are dollars per mile, right? The units are dollars per mile. So dollars per mile, okay, what does that mean? If the units are dollars per mile, it means that the rental cost increases by 20 cents. Excuse me. By 20 cents for every additional mile. Okay? For every additional mile driven, it increases by 20 cents every additional mile. So this is an important point because the slope is not merely just a number. It has applicable principles and practical things as well. So very, very important that this is understood. This is an important point. So the slope is not merely a number. Slope represents a rate of change, okay? A rate of change. Now, suppose if you had two students and they calculate the slope between, let's say you have two students who calculate the slope between 2, 4, and 8, 16. Okay. Let's say student A says that, M is equal to 2, and student B says the graph rises 12 units so the slope is 12. Okay. Who is correct and why? Well, student A is the correct one. Okay. Student A is correct because the vertical change is 16 minus 4, which equals 12. But slope is not merely vertical change. Slope compares vertical change with horizontal change. Okay. So, for example, delta y is 12, but delta x is 6. So 12 divided by 6 is 2. Because slope is a ratio of two changes. That's the big idea. Slope is a ratio of two changes. That is the deeper idea. So a final review is this. When we find the slope, we need to understand that the slope is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so you have to remember these four things, these four ideas. Slope, the slope measures the change for delta y, delta x, or the change in y over the change in x, or the rise over the run. Secondly, the subtraction order must remain consistent. Thirdly, slope, positive slope rises, negative slope falls. Okay, so positive slope, and negative slope. Okay, positive slope rises, negative slope falls. Fourthly, the applied problems, like the one that we just looked at, in applied problems, always interpret the slope using the correct units. So in the next video, we will study two special cases, something called zero slope and another called undefined slope. And again, thank you for watching.